make sure you clip those for me.
Yeah.
Say hello to this.
What's that?
Say hello to
Oh yeah, it's people in North Carolina have been using my stuff. I love it.
Oh, really?
Yeah, I guess some guy in North Carolina has been showing my videos because they use the same curriculum.
A teacher?
Yeah, it's funny. I got some weird messages just the other day. I was like, oh, okay.
Wait, the teacher shows
Some of the kids said it. We're using these notes in our classes.
So he doesn't teach them?
I don't know if he's copying them or what. It's kind
Probably
of
just sits in
funny.
the corner on his phone and lets
What's that?
Probably sits in the corner on his phone and lets you.
1 hour bill? Maybe I should charge him a bill. Maybe I should get like 25% of his paycheck or something.
Not a lot better.
No, I put them out there for you guys if you need them. So here's the deal. Hey, did everybody get notes? That's my first question. Okay. Let's do this. Let's plan on this. And you guys tell me if you're okay with this. The 7.1 stuff, if you turned it in, great. There's also an online that was with that. You remember that?
Yeah.
I'm not going to pull that in until Monday. So if that's kind of escaped your mind a little bit over break, try and just do me a favor. Double check and see if 7.1 in that online is something you need to finish up. Does that make sense to everybody? I don't care if you do that now or later, but I won't pull that in until Monday. Okay? All right. And if you didn't get 7.1 practice puzzle into me today, when do I need it? Monday. Okay. Hey, good news. Good news. Pretty simple today. So if you'll everybody will come on up here with me and listen up, let's get started. Guys, 7.2 is titled Properties of Parallelograms. Frisbee, you want to see what we're trying to answer here today?
Yeah. What are the properties of parallelograms?
Properties of parallelograms. First of all, in order to answer what are the properties of parallelograms, we're going to go ahead and use properties to find what?
Length.
Side lengths and what else? Angles. And this is going to be pretty simple today. And then we're going to use parallelograms in the coordinate plane. We'll talk about some coordinates there. Okay, parallelogram. Guys, how do you define a parallelogram?
It's a quadrilateral with both pairs of opposite sides.
Okay, a quadrilateral with both pairs of opposite sides parallel. Excellent, excellent, excellent explanation. Good. Okay, and that is the definition, by the way, folks, in case you didn't catch that. Here's a parallelogram for you. Maybe we'll draw one like this. And I'm going to kind of elongate this a little bit. Okay, parallelogram. What's true about the top and the bottom? Okay, so we put a little arrow like this and this to indicate that they're parallel. And then maybe over here I might put 2 arrows to indicate that this side is parallel to that side. Okay? So it's a 4-sided figure because it's quadrilateral. And left and right are parallel. Opposite sides are parallel. Is it okay to say that? Opposite sides are parallel? Yeah. Is that a fair statement? Okay. All right, quadrilateral. That's simply any what?
4-sided.
So besides a parallelogram, give me another name of a quadrilateral. What other shapes have 4 sides? A square or a rectangle. Okay, how about a rhombus? Stop signs ain't side. That's not going to work. Okay. All right, diagonals. A diagonal is a segment that connects 2 non-consecutive sides in a polygon. So if I had a 4-sided figure like so, here's a 4-sided figure. My diagonal would go from here to where? Top left, bottom right, or top right? Top right. There's my diagonal right there. All right. It's 2 points or 2 vertices that are non-consecutive where you can set, let's connect a segment there. Interior angles. You know what interior angles? They're angles where?
They're inside the shape.
Okay. And then a segment bisector is a point, a line, a segment, or a ray that passes through the midpoint of a segment. Okay. Segment bisector is anything that takes one segment and cuts it into how many equal parts? 2. I don't care if it's a point doing it. I don't care if it's a segment doing it. I don't care if it's a ray doing it. If it's a line doing it. Segment bisector cuts stuff in half. So I'm going to write this. Cuts stuff in half. So I think we've got a pretty good toolbox here to start working here. Let's roll here. A couple of theorems that are going to be pretty important for you. I'm going to highlight these here, so let's do this. These are pretty gosh darn important. Might want to highlight it, star it, whatever. Okay. 2 theorems. You ready? Okay, I'm ready. First theorem is called parallelogram opposite what? Sides theorem. Okay, how about a volunteer to read this? Thanks, Michael.
If a quadrilateral is a parallelogram, then its opposite sides are congruent.
Okay, so we're saying if you have a parallelogram, so if this, I'm going to kind of write it this way.
Well,
if
then.
And don't worry about this too much. If you have what first? If you have what shape? If a quadrilateral is what? Okay, so if you have a parallelogram, okay, meaning if you have, what makes this true right off the bat? Why is that a parallelogram, kids?
The arrow say so.
The arrows indicate, hey, opposite sides are what?
Equal.
And isn't that, well, not equal, but
Parallel.
parallel. This indicates it. And that's what, hey, go back up to the definition here, kids. A parallelogram is a quadrilateral with both pairs of what? Sides are parallel. Okay, if this is true, if you have a parallelogram, then it says its opposite sides are what? So then it means, okay, then it means then in this parallelogram that we have, well, that's a bad drawing. Close. Ah, shog diddy doody, the cat and the kitty.
Do one of those like geometry things that have all shapes on them. Just trace it out with.
How about I do it this way? Then this. Okay, again, these are what, kids? These are, and these, the left and the right are what? Okay, it says if you have a parallelogram like this, then what did it say about opposite sides? So I'm going to put some tick marks up here in red. That means that this distance is the same as this distance. Left and right sides are the same distance. And then I'll put some tick marks up here to indicate that these are the same distance. Okay? So if you have a parallelogram, then opposite sides are what? Congruent. Okay?
I love that.
So what if I told you that I had, well, we'll look at an example. Okay? All right, so that's the parallelogram's opposite side theorem. I'm going to come up with an abbreviation for this. Is that okay? I'm going to call this POST. Parallelogram opposite sides theorem. In a parallelogram, opposite sides are what? That's all it's saying. In a parallelogram, opposite sides are equal. Okay, anybody going to guess what I'm going to go ahead and call this one?
Both.
I call this almost both. Almost both, because we got that little. All right, never mind. That was dumb. Coat.
Okay.
Not boat, not coat, but boat.
Sounds like something you do with a pipe.
Pull it out.
Like,
What?
no. Not going there. Okay. Not going there. Okay. Michael, you want to read the definition of the parallelogram opposite angles theorem?
Yeah. If a quadrilateral is a parallelogram, then its opposite angles are congruent.
Okay, so what this is saying is the following, kids. It's saying if this, if the shape is what again? So if I have a parallelogram again. There's my parallelogram. If I have a parallelogram. So parallel to here. So if you have a parallelogram, then it says the parallelogram opposite angles theorem says opposite, not sides, but opposite angles are congruent. So then you're going to have, well, here's my parallelogram. Oh, that's bad. Very bad. There you go. Okay, parallelogram still. All right, so if I said, hey, opposite angles are equal, this angle down here with one arc would be congruent to the one opposite of it with one arc up there. And then these two angles right here in purple would be equal to each other. So if this is 120 degrees up here, what's this down here? 120 degrees. Okay. Parallelograms opposite sides theorem, opposite angles theorem. Just remember, stuff that's opposite, they are what? Congruent. Okay. All right. Anybody need more time? First page. Feeling so far so good about the theorems? At least got the information down. Let's put them into action here because this is going to get pretty simple. Okay. So, in example 1, it says using what? Properties of what? To find the values of. Okay, I think I'm gonna do my work for finding x on the left, and I'm gonna do my work for finding y on the right. Okay, is x associated with an angle or a side here, kids?
Angle.
An angle. Okay. 2x specifically is which angle?
54.
I guess maybe how are you gonna set an equation up for this, kids?
It's half this.
Okay, this angle right down here, 2x, has to be equal to the angle opposite. Do you know the angle opposite?
Yeah.
Simply put, this is just simply 2x equals what, kids? So what's 54 divide 2?
27.
That's pretty simple, wasn't it?
20 equals 3.
Okay, so Michael, or I'm sorry, Adam.
Oh, really?
I was talking to Michael
No,
there.
you weren't.
No.
No.
Alright, listen. There's 2 Michaels in here. Could have been.
Because you're not brother.
Yeah.
Yeah, I know. Yeah. So you're just doing it right now.
I'm so bothered.
I've done it to Ty. Fleshner, I've done it to you, haven't I? Called you your brother.
You should have called me
I haven't called you your brother yet.
Someone's supposed to call you.
I haven't called you Trey, have I? Do you want me to? No, don't do that.
Call him, Trey.
I told Brad to call me Bob today.
Yeah, it didn't work.
Did it work?
Should have
No?
been like, that's
Okay.
against my religion.
Adam, you were ahead of me on Y. Help me out. What were you talking about here?
I don't know, you split
20 equals 3y minus 1.
Okay, why can I say 20 is equal to 3y minus 1 here,
They're
kids?
parallel. Parallel.
And they're sides. And they're sides specifically of a
Parallel.
parallelogram. We just got done talking about sides opposite the parallelogram are what? So I'm going to say 3y minus 1 is... Okay, you guys roll. Tell me what you have for y. Y is 7. Add 1, divide 3. 21 divide 3. You bet, 7. That's pretty easy. Okay, again, 2 theorems. Parallelograms, opposite sides theorem. Opposite sides equal. Parallelograms, opposite angles theorem. Opposite angles are
Equal.
all right. Set stuff equals solve. Okay. More theorems. Let's move. How about a backup? You guys have what you need there?
Yeah.
I know I'm going quickly. I want to make sure I sometimes get in a hurry and I forget to ask. Good over here? Good over here?
Not yet. Just wait.
Okay. Yell at me when you're ready, okay?
What was that?
You good, Martin?
All right. Thank you. All right. More theorems here, kids. Let's talk more about parallelograms. This is important right here. I don't think I've got this highlighted, though, do I? Darn it. Okay. Parallelograms, consecutive angles theorem. Consecutive means one right after the other. Okay.
Wow.
Anybody have a guess what I'm going to call this? PCAT. Consecutive angles theorem. In a parallelogram, kids, in a parallelogram, if a quadrilateral is a what? Then its consecutive angles are... So here's what I'm going to say. What this is really saying, I'm not going to put if then. What I am going to tell you is this. I'm going to draw a parallelogram here as best I can. Here's your parallelogram. Okay? If I call this angle A and angle B, these are consecutive. They're not opposite of each other. They're consecutive, one right after the other. This means then that A plus B should equal what? Okay. They're supplementary. So 2 consecutive angles, one right after the next. Hey, have a question. If this is angle A and this is angle B, what's this angle up here?
C.
B.
Have to be the same as B because it's what type of shape?
I thought you were just going in order.
Well, it could be C if C was equal to 15.
But the assumption is, and we just got done talking about opposite angles, if this is angle B down here, what's this have to be? And what's this have to be down here? All right. So that's all that's saying, is if you have a parallelogram, then 2 angles consecutive, not across from each other, but one angle followed right by the next. They're supplementary, add up to 180, okay? PCAT. Okay? Parallelogram diagonals theorem. We'll label this PDT. That'll be our shortcut when we have to do proofs next section. If a quadrilateral, again, is what?
That's not
if a quadrilateral is what?
Parallelogram.
Parallelogram. Okay, again, what kind of shape are we assuming here?
Parallelogram.
Okay, there's my parallelogram. Then it's telling me that the diagonals for this, the diagonals do what to each other? This diagonal and this diagonal cut each other in half. So if I tell you that the distance from here to here is A, what's the distance from here to here? And if the distance from here to here is B in a parallelogram, what's the distance from here to here?
Pretty obvious.
Okay? So that's what that's saying. If you have diagonals, they cut each other in what? Half. Okay? They cut each other in half. They bisect each other. Okay, are we clear on all that?
Yes, we're crystal clear.
Beautiful. Okay, so let's talk here, kids. I don't know if I have a diagram for this next one. I think we'll draw it. But we're going to use those properties of parallelograms. Consecutive angles theorem, diagonals theorem. It says using properties of a parallelogram. It says in parallelogram, let's get this drawn. Go ahead and draw a parallelogram, PQRS. Oh, that's a beautiful parallelogram. All right, I'm not going to talk for a while. I'm going to let you guys do some thinking. It says in parallelogram PQRS, angle P is 4 times angle what? Q. Find the measure of angle what?
P.
Well, I was right. Think about your angles. Which one's the bigger one?
P.
P. Yeah. Meaning Q is the smaller one, right? I have a question. Do we know the measure of angle Q?
No.
So is it okay for me to call the measure of angle Q
X.
X degrees down here?
Yes,
Okay. All right, so Q is X degrees. How is angle P related to angle Q?
It's 4 times bigger.
4 times bigger. So what will be an expression in terms of X for angle P?
So
4x.
4x plus x is equal to 180, right?
Is there money there?
That's like a little harder.
There, let's go with X.
It does look like a little hard.
Guys, what theorem could I use up here to figure out my angle P
X to
now?
the harp power.
Yeah.
Are these opposite angles or consecutive angles?
Consecutive.
Consecutive, one right after the other. So up here I can use parallelogram consecutive angles theorem, which states if a quadrilateral is what?
Parallelogram.
Do we have a parallelogram down here?
No.
I mean,
And
there's
its
no lines.
consecutive angles are what?
Yeah, we don't know.
Yeah, there's not the arrows on the lines.
Well, it's just
Yeah, but it says right here in what?
Well,
Tells me right
okay.
there, right?
I guess.
So how would I set this up then?
4x plus x equals 180.
4x plus x equals what?
180.
Okay, so the 4x and the 1x combine to
5x. So 5x equals 180.
so what's that make your x value when you divide, kids?
Too much. 36.
Okay, now what angle am I trying to find here?
P.
An angle P is represented by which expression?
4x.
So how am I going to find the measure of angle P?
4 times 36.
144.
4 times what?
36.
144.
Grass.
Degrees Celsius.
So angle P is hot.
How does it smell?
I wish that's the temperature right on. That'd be nice.
What did we get down to here? About didn't we get down to like negative 31 degrees in Laporte?
Yeah.
I mean, it was.
With the windshield, it was like
That says 144 degrees in there.
But once you get below 0, it like all feels the same.
So I think you're
I walked outside and like the spit on my lips froze to my lips.
So here's the deal. I think on Saturday and Sunday it's going to be close to 45 or 50 degrees. That's an 80 degree swing in about what? 4 days?
Climate change.
Hey, back up. Everybody with me. Parallelogram consecutive angles theorem. You understand that P and Q are consecutive here, right?
Yeah.
And this is a parallelogram, so these two consecutive angles must have to 180. Where did the x and the 4x come from? One angle being what?
4 times the
4
other.
times the other. Okay. All right. Next page, last page. Let's talk about stuff within the coordinate plane here and other stuff. So first of all, I'm going to blow this one up a little bit. Okay, it says writing a 2-column proof.
I thought we were done with
Have you done a lot yet this year? Or have you done a lot? Did you do a lot more last year?
Hey, we're already at 12 the way through the year.
Did you
Isn't that crazy?
Honestly, it's not that bad.
Think about it this way. We've got POT, we've got PSAT.
We got POTUS.
All right. Here's what we're going to do. Where did I set my pen down at? Right there. All right. Guys, write 2-column proof. Well, first of all, you always know what step 1 is going to be, so get that started. So I'm going to make my little T-chart. Okay, step 1. Step number 1 here, kids. What am I going to write? A, B, C, D, and what?
Or parallelograms.
I love it.
And I'm going to abbreviate a bit. Our p-grams. I call parallelograms p-grams. So I call them like this: PGMS. I use PGM for parallelogram. Okay. If you want to do the same, I'm okay with that. That's given to us, isn't it? A, B, C, D, and G, D, E, F are what shapes?
That's given.
That's given. Okay. What are we trying to show then, kids? We've got to show angle B is equal to what?
F.
No problem.
It's almost like it's reflected over the y-axis.
Kind of
and then
is.
shrunk by a
Okay?
factor
And you're
of
going to have to
2/3.
think about. Here's the deal. These are what types of shapes?
What's the title of this teacher?
Parallelograms.
Okay. Well, isn't B going to be the same as this down here? And isn't F going to be the same as this over here?
Yeah.
Because
Oh my god, those are supplements.
they're in a parallelogram, they're opposite angles, aren't they?
Yes.
Okay, so that would be POT. So here's what I'm going to write. Step 2. Angle B has to be congruent to, all right, I'm going to call this angle CDA. Is that okay right in here? See what I'm saying there?
Yes.
Angle CDA. And also, well, I'll just say step 2 is POT. In a parallelogram, opposite angles are what? In a parallelogram, what's true about opposite angles? They're the same. So isn't that really saying parallelogram opposite angles theorem right there? Okay. All right. What can I say about angle F? What's angle F congruent to? EDG? How do you know that? Same thing. In a parallelogram, F, EDG is right here. So, POT again, right? In a parallelogram, opposite angles are congruent. Parallelograms, opposite angles theorem. Okay? Well, guys, what must be true about angle CDA and angle EDG then?
It's not a word.
Why are they the same?
Alternate.
One angle across from each other are called what? Starts with a V.
Vertical.
Vertical angles. So right here, step 4, guys. Can't I say angle CDA is congruent to angle EDG here and here? Aren't these equal right here, guys?
Yes.
By vertical angles?
Sure.
So can I put VAT? Is that okay? If I put VAT, what's that mean, kids?
Vertical angles theorem.
Well, guys, what's CDA congruent to?
So that's substitution.
Yep. What's EDG congruent to? So by step 4, I can make step 5 statement be angle B then must be what? Angle B must be congruent to angle what? By what? We substituted stuff. Yep, because CDA is the same as what? Oh, B. So in for CDA, plug in B. EDG is the same as F. So plug in F. What are we trying to prove here, kids? Did we do that? What was the last step again there, Mr. Aronson? Thank you, Adam. He thinks I don't know, doesn't he? Did I spell that right, kids? It looks wrong.
It looks really long.
I don't really care, so.
I just wrote
All right. That's our proof for the day. Did you guys follow me through that? It's not that bad. Not that bad. Again, the assumption is every shape that we're working with is what type of shape? Parallelogram, okay? Here we go, kids. It says find the coordinates of the intersection of the diagonals of A, B, C, D with vertices. We got to find the coordinates of the... Where the diagonals do what? Let's plot these points. Let's have some fun. Blow this thing up. What points are we plotting? What's A?
1, 0.
1, 0 is right here. A.
6, 0.
6, 0. B.
5, 3.
Right 5 and up 3. C.
0,
I'm going to guess D is going to be 0, 3.
Sure.
Is that right?
Yeah.
Okay. So,
What the heck?
let's draw a parallelogram.
Okay. Dang it. I did. What? I plugged them really bad. I did it totally wrong.
You guys okay with my parallelogram there? I might need a ruler or a straight edge to do this, but I think if you draw stuff as straight as possible and try to find the intersection, you should be able to. But kids, it shouldn't be that hard, because think about it this way. How far over, isn't the diagonal like going over and up right here? How far over on this diagonal? Talk to me this. Listen carefully on this. This is good stuff. If I go from, say, A to C for a diagonal, kids, you hearing me? All right, so if I go A to C, how far right do I go from A to C?
5.
Well, I go from 1, how many units do I go? 1 over and up.
3.
Okay, so think about it this way. Instead of going over 4, we could go to the midpoint. Because remember, diagonals do what to each other? They intersect, but they cut each other in half. Yeah, they bisect each other. So if I, instead of going over 4, I could go over 2. And instead of going up 3, I could go up what?
1.5.
Looks like that point would be at 3, comma. Okay. Now, if I didn't like that, I could draw the other one in.
I want one that's on a point. I don't like
I know this stuff, but again, do you understand my deduction there? Saying, well, to get from this diagonal A to C, it's going right 4 and up 3, so we would cut that in half. Since I know diagonals bisect each other, I would go right 2. So right 2 puts me at the x coordinate of what? 3, and then up. Instead of going up 3, we would go up. Where's that land us at then?
3, 1.5.
Yeah. So what point are they asking for there, kids?
The intersection.
Okay, so the intersection point, I'm going to call it P. Intersection occurs at, what coordinate do we come up with there, kids?
3, 1.5.
Because we understand that diagonals do what to each other in a parallelogram? Cut each other in half. Okay, so if you can find the distance, say, I can count left and right, and I can count up and down. We'll count left and right, cut it in what? And count up and down, and cut it in half. Go from a starting point,
I love it.
find your midpoint. Okay? Okay, or I could have just found the midpoint. Hey, could I have done this? I have an idea. A and C, aren't they diagonals?
Sure.
Let's find the midpoint. The midpoint for A and C, what's 1 plus 5?
6.
Divide that by 2. Ooh. How about the next one? 0 plus what?
3.
Divide that by what?
1.5.
Ooh. Works that way too. Did I even need to have the graph there?
No.
If I would have understood that A and C were opposite of each other, I guess I'll just look for the midpoint. Because isn't the midpoint going to be the point that cuts a segment into 2 equal segments? So instead of drawing that out, I could also find the midpoint of 2 diagonal or 2 opposite angles. Okay? All right. I like number 5 because that leads right into this. 3 vertices of D, E, F, G are given. I'm going to plot this in decimals. Okay, you're going to help me.
It's a triangle?
No. It says 3 vertices of parallelogram. D, E, F, G are what? D is what?
Oh, we gotta find.
Yeah, and again, I love having you guys plot stuff in decimals, so let me get this loaded.
I did it probably 4 hours nowadays in my office.
What are you playing a keyboard or you by yourself? That's impressive.
I mean, I played with my family for a little bit, then they left.
Okay, kids, I'm going to make a table here. You're going to help me. All right, I'm going to make my table here for points. And I want to connect my points. And orange is my favorite color. What's the first point or coordinate of the first point? Negative 1, 4. Next one. 2, 3. Next one.
4, -2.
4, -2. Okay. Our job is to figure out where in the world the last coordinate is. Where in the world that last coordinate is to make this a parallelogram. Okay? So here's how we're going to do this. Here's how we're going to do this.
I know where it is.
What's that?
I found it already.
You found it?
I think so.
Think so?
Yeah.
A couple of ways to do this. And I'm going to take a screenshot here, and we'll draw on this. So, hey, give me thoughts. What are you thinking about doing?
Well, see that
Putting it at 1.
Go ahead, Keegan. I'll get back to you. Go ahead, Keegan.
Well, what I did was I just counted, like, you see the point at the very top?
So top left or top right?
Top left.
Top left?
I just counted from the top right point to the top left point. And I looked at the bottom. And
So you went up 1 and over 3?
Yeah.
So is that what you're applying down here?
No, yeah, you got to go, up 1 over 3.
So up 1 over 3, and then you need to apply that to the opposite side. Go up 1 and over 3, is that right?
Yeah.
Why do you need to do that?
Because if you go down and over 3, it's not...
Right. You guys remember what we said? First of all, we're trying to get a parallelogram, right?
Yeah, it's have the same slope.
Yes, right there. When we get back to coordinate plane stuff, we understand that if we're going to have a parallelogram, 2 lines are parallel, opposite sides would be parallel. Those opposite sides in the coordinate plane, what would be true about their slopes in the coordinate plane for opposite sides? They would be the same. So this is going to take me right to here. Which coordinate is that, kids? 1, -1, we think. Okay, well, let's go back. Let's punch that in there. Okay, let's do that. Let's go 1, -1. So 1, -1. Next one then would close it back up to -1, 4.
It looks so weird, but
Look like a parallelogram, guys? So what's our coordinate?
I guess.
What's our coordinate?
1, -1.
So when I think of something like this, I'm going to tell you G is at the point 1, -1, but on this right here, use what when you have to put those points in? I think use decimals to get a visual, then check opposite slopes. Okay, check your opposite slopes. All right, kids, I have 3 things for you first. Okay, number 1 is this. At some point, and maybe it's this hour, I don't know, at some point, check your JMC, because that's all up to date. I want you to make sure if you have anything out, get that to me. Okay? Number 2, some of you turned into 7.1 stuff. That's awesome. Okay? Don't forget there was an online page with that. I'm not going to pull stuff in until Monday. If you didn't turn to practice 7.1 in today, when do I need that? Monday. Lastly, I sent out a new big ideas for this stuff. So you have about 13 minutes. I'd like you to get in there if you've got everything done and start on the new 7.2, okay? Questions for me at all? Somebody had their hand. All right, guys, get into big ideas and get rolling, all right?